Section 6.7, polygons in the coordinate plane. What we're going to do is classify them. So the thing that you can't do is just draw the picture using the ordered pairs and go, yep, that's a rectangle. You have to actually explain why it is. So I'm going to show you different things today to help you to pick which one it could be. So the first thing that might help is looking at which formula could you use if you're going to do certain things. So when you look at the distance formula, the distance has to do with length. So anything that you are looking at, do I need the sides the same? Do I need the diagonals the same? What kind of thing are you doing? You're going to use that distance formula. Remember, on a graph, you're usually not going to use distance formula. You usually use Pythagorean theorem. So a squared plus b squared equals c squared. They are exactly the same thing. So I'm going to show you a couple of those today. Now, when do you use it? When you're trying to figure out, are the sides all the same, or two specific sides the same, or are the diagonals the same? Okay, so when the sides are congruent or the diagonals are congruent, that's when you're going to use either the Pythagorean theorem or the distance formula. When would you use midpoint? When you're trying to figure out the coordinates of the midpoint of a side, usually that one is for a trapezoid. And then sometimes you have to use it when you see if the diagonals bisect each other. What you would do is you would use the midpoint formula to find the midpoint of one of the diagonals. You do the midpoint formula to find the other one, and they should be the same. If they're not the same, then they don't bisect each other. So they have to meet in the middle at a specific point. We're going to do something like that today, but we're not actually going to use the formula. We can kind of eyeball the midpoint, and I'll show you what I'm talking about in a little bit. And then slope formula, that's usually when you're trying to figure out if things are perpendicular. So when you're trying to figure out, are sides perpendicular or are the diagonals perpendicular, that's what you're trying to use the slope formula for. And usually if it's on graph paper already, it's just the rise over run part. Okay? So used to determine when opposite sides are parallel. The slopes would be the same. I'm going to put that on here. Slopes are equal. Diagonals are perpendicular. The slopes multiplied equal -1. And of course, sides perpendicular would be the same thing. So once you find out what the slopes are, if you multiply them and they equal -1, they are perpendicular. If you look at the two slopes and they're the same, then it would be parallel. So 3 different formulas. You don't have to memorize the formulas. You just have to memorize kind of when to use them. So we're going to go through quite a few little examples here so you see, oh, this is how you do this one, or here's another way to do this one. And I'll show you a couple ways for some of these. Okay, so here's the first one. Classifying a triangle. Is the triangle scalene, isosceles, or equilateral? You cannot just put the ordered pairs on the paper and go, yep, I think this one's scalene. No, you have to show it, and it will say show it. So what we're going to do is, since we're talking about scalene, isosceles, or equilateral, we want to know if the sides are the same or not. We're going to use the length one, or the first one we looked at. So I'm going to find the length of all of them. You can use ordered pairs, but this way is easier. I am just drawing in the triangle, and I want to know the length of that segment BC. So I'm going to do colors just so you can kind of see them. BC is going to equal, this side is 4, the other one is 3, and you're going to do the Pythagorean theorem. So the square root of 3 squared plus 4 squared. Now, remember with the Pythagorean theorem, it kind of looks like this. If you solve it for C, that's why it's the square root of that. And I'm just kind of doing it all in one step. So every single time that you do this, it's always going to be the square root of 3 squared plus 4 squared, or whatever the two numbers are. 3 squared is 9, 4 squared is 16. Together, those are 25. And we do know that that equals 5. Okay, so you're going to have to produce the length there. Then we're going to do the same thing on the other sides. So if we do this one, it's going to be 3 and 4. 1, 2, 3, 4. Okay, so is AB going to be the same? If you have 3 and 4, well, you know that it's going to be the same. As long as you set it up, you can go directly to 5 if you want to, because we just did that one. So if you recognize that it looks very, this should be squared. If it looks very similar to something else that you did, you don't have to do all the work again for that one. Just write the number. And then we have to do the last side as well. I'm going to go with, we'll go pink. So we go to this one. This is 1 and 1, 2, 3, 4, 5, 6, 7. So AC, and make sure you actually put the letters in there and actually label them so I know which side is which. So the square root of 1 squared plus 7 squared. I know for sure that that's not going to equal the other sides, but I want to see what it is anyway. 7 squared is 49, plus 1 would be square root of 50. And you don't have to go to decimal places. Now the reason I don't do that on these are that what if you had the square root of 49 and the square root of 50? They're super, super close. Or the square root of 32 versus the square root of 33. Okay, so I'm going to get my calculator and tell you how close they are. So if I look at the square root of 32, it's 5.7. If I look at the square root of 33, it's 5.7 when you round it. But is the square root of 32 the same as the square root of 33? No, they're close, but they're not exactly the same. That's why I don't want you to go to decimal places on these, because people are tempted to make them the same and name it something different when they're really not the same. So here we have two sides the same, which basically cuts scalene out of there, but it isn't equilateral either. Equilateral means all the same. So for this one, we're going to go isosceles, and we're going to just leave it 5, 5, and square root of 50. Okay, so this one is isosceles. You can't just name it, you have to show what we just did. Now, let's do another one. Is it a right triangle? Okay, and explain. So with this one, we already know it's isosceles, but we don't know for sure if it's a right triangle. So let's break that down and try to figure that out. Let's go here. Now, if it's a right triangle, we know that it has to have a right angle in it. Do you suppose the right angle is right there? No, is it right there? It's probably the one that looks like a right angle. So what I'm going to do is I'm going to figure out what are the slopes of those two sides, and when I multiply them, do I get -1? So don't do the ones that don't look like a right angle. Do the one that kind of does look like a right angle. So we want to know this angle right here, is that a right angle or not? So the slope of AB is 3/4. Now, how did I get that without using ordered pairs? I'm looking at the triangle that's already there, rise over run. Okay, so for that one, rise over run. Okay, and it is positive because it's going up. If I look at the other one, BC, the slope of BC, I'll try to get that off of there. Okay, is 4/3, and it's negative. Okay, so the rise would be 4, the run would be 3, it's going down to the right, so it's negative. And what I'm going to do is I'm just going to show the product of the two. And it does equal -1, so yes, right triangle. Now, if you got something like 8/7, that doesn't equal -1, so then it would not be a right angle. So this one is an isosceles right triangle. Okay, so I want you guys to try this one with me. So grab a piece of graph paper, put it right on the assignment page, whatever you're going to do the assignment on today. I'm going to pause the video a little bit until you guys get it graphed. So we're trying to classify scalene, isosceles, or equilateral. That has to do with side lengths, so we're going to figure out what those side lengths are. Again, make sure that you put the letters of the coordinates right next to it, and you actually have to define them as well. So I'm going to go with EF first. It doesn't matter which one you do first because you have to do them all. So I have a 2 on this side and a 4 on that side. So EF equals the square root of 2 squared plus 4 squared. So 16 plus 4 would be the square root of 20. One thing that you can't do is go, oh, 2 squared plus 4 squared is 6 squared. No, you don't add the 2 and the 4 together and then square it. You square them separately, then add them together. Okay, then we're going to go to, let's go DF. 2 and 1, 2, 3, 4, 5. So DF is going to be the square root of 2 squared plus 5 squared, which would be 25 plus 4. That would be the square root of 29. And then we have to do the other side as well. One and 4. DE is the square root of 1 squared plus 4 squared. That would be 16 plus 1, or square root of 17. So are any of those the same? No. Nope. So this one is scalene. Okay, so I need all of this. Doesn't take super long. Now, if you actually did DE and it was the same as 2 squared plus 4 squared, set it up and just write square root of 20 because you've already done it. Okay, or you can put a DE equals EF. You can put them kind of in the same little group. Okay, here's one that has to do with a parallelogram. So first you would graph it if it wasn't graphed already. And they want to know, is it a rhombus? So we have to think back, how do we know something is a rhombus? There's a couple different things you can do. First thing, diagonals have to be perpendicular. So if you did that, you'd have to find out what the slopes of the diagonals are, multiply them, and if they equal -1, they're perpendicular. If they don't equal -1, they are not perpendicular. What's the other thing about rhombuses that we know? Something about the sides. What are they? Congruent. So you could find all the lengths of the sides. They should all be the same. So I'm going to show you both. If it doesn't say prove this is a rhombus using distance, then you can do whichever you want. So this one doesn't have a little explanation, but if it said show this as a rhombus using slope, you'd have to do the diagonals are perpendicular. If it said using distance, you'd have to show that all the lengths of the sides are the same. If it doesn't say any of that, you can do either one. So I'm going to do distance first. Okay, so I'm going to do this one right here first. It is 1 and 4. So we're going to go BC is equal to the square root of 1 squared plus 4 squared. So square root of 17. I need to do one that's next to it to see if it is the same. So I'm going to do CD. That would be 2 and 4. That's 16 plus 4, so that would be square root of 20. Is this thing a rhombus? They're not the same, are they? So why go through all the work showing all 4 if you already know the first 2 are not the same? Okay, so I'm going to say not a rhombus. Sides not congruent. Now, what if you did that same thing and you wanted to use slope on that one? Okay, so I'm going to put an or here so you don't have to do both. So I'm going to put or slope. So I'm going to go with this one. And I'm going to count all the squares. 5 and 6. So the slope is of AC is 5 over 6. I also need to do the slope of the other one. Slope of BD, and that's this one. 2 and 3, negative 3 over 2 is 5 over 6 times negative 3 over 2, negative 1. No. Remember, you can kind of tell if they're the same. If they look like the same numbers, but one of them's flipped over an opposite sign, negative reciprocals, then they are. So this one is not a rhombus because the diagonals are not perpendicular. So I'm going to say diagonals not perpendicular, not a rhombus. Okay, so do some sort of explaining there. You have to kind of show one or the other. Now, I want you guys to do this one with me, this next one. So grab some graph paper, and this one's going to be a parallelogram, so it has 4 ordered pairs. I'm going to pause this while you guys graph. Okay, so what does this one look like to you? Kind of looks like a rhombus, but it could look like what else? Maybe a square. So have something in mind, but you're not going to say, yep, I think it's a square. You have to show it. So we are going to show what this one is. So first we're going to go with, the first question is it a rectangle? So we're going to kind of show that first. I'm going to do it right next to it here so we can kind of see the picture at the same time. Or maybe I can move it up just enough. I'm going to go to there. Okay, so is it a rectangle? Rectangles have congruent diagonals or 4 right angles, correct? So you can do whichever one you want to. Unless it tells you, then you have to do the one. So I'm going to go up here. Rectangle. Which one would you like to do? 4 right angles or congruent diagonals? One uses slope, the other uses distance. Okay, so let's do 4 right angles. You could do the lengths of the diagonals too. That would be just the Pythagorean theorem. So let's find all the slopes and see what happens. Okay, so on this one, you have a 1 at the top and a 3. So the slope of PQ equals negative 3. Now, what else do we know about this one? Would that be the same? NM? Sure looks the same to me. So I'm going to say the slope of, I'm going to leave a space though. Okay, so the slope of NM is also negative 3. And then the ones at the top, I'm going to do those different colors. I'm going to go 1 and 3. So your slope there is NP. Positive 1/3. And would this one be the same as that? Yep. So slope of QM or MQ equals 1/3. Now, what happens when you multiply these? Do you get negative 1? Yep, they're negative reciprocals. What happens when you multiply these? Do you get negative 1? You should, because it's the same thing. Negative 3 times 1/3. If we do the other two, would it be exactly the same thing? So if you multiplied 3 times, or -3 times 1/3, it's going to be that way all the way around. So all 4 pairs of sides equal a right angle. So you have to show at least 2 of them, you know, opposites for sure. And you could show each set of 4 if you wanted as well. So we do know that it's a rectangle. So you're going to say yes. Now, it also says, is it a square? So I'm going back to this one. If you're showing that it's a square, we've already showed that it's a rectangle. What other shape would we have to show that it is? A rhombus. And we know that rhombuses have 4 congruent sides or perpendicular diagonals. Okay, so you can do whichever one that you want. Now, some of them are easier than others. Okay, for instance, we already have the squares drawn for the Pythagorean theorem. Let's just use them. So I'm going to do square kind of off to this side. Let's go with this one. Okay, so if my lengths of the sides are 1 and 3, I'm going to say PQ, distance PQ, is the square root of 1 squared. Oh, that doesn't show up very well. Hold on. Okay, so PQ is the square root of 1 squared plus 3 squared, which is the square root of 10. I'm going to do QN. It's 1 and 3 again, isn't it? So it's the square root of 1 squared plus 3 squared, which is the square root of 10. And you're going to keep doing that, and they are all going to be the same. So NP is the square root of 1 squared plus 3 squared, and NM is also the square root of 1 squared plus 3 squared. Okay, now I put equals in all of them, so we're going to say yes, it's a square because it's a rhombus and a rectangle. Okay, what if you didn't have to show it was a rectangle first? You'd still have to do 4 right angles, 4 congruent sides, or 4 right angles, congruent diagonals. You'd have to do something to show you know, what the square is. And generally, if you go rectangle and rhombus at the same time, automatically a square. Now, we're going to do one more. I think there's one more left. I have to kind of look. Yep, it's a kite. We're going to do one together, and then we're going to do one in the homework. So with this one, it says, the kite is shown below. What's the most precise classification of the quadrilateral that forms by connecting the midpoints of the sides? So remember the formula when we did midpoints? I said you don't always have to use the formula. When you're looking at this one right here, can you not say the midpoint is right there? You can kind of see it, right? It's the ones that you don't know for sure that you would want to use the ordered pairs for. So with this one, what I'm looking at is I am thinking that this is the midpoint right here. And if you can prove that, you'd go, okay, I'm going up to, right to, up to, right to. If you hit both of those vertices, you have the midpoint. If you have something that's different as you go up, like up one, right one, and you don't go up one, right one to hit a vertice, then you don't have it. Okay, so there's one. This would be another one. Here, would this be the midpoint right there? Let's check. If you go right 4 down 2 and go right 4 down 2, you do hit a vertice. And if you do that, you have it. So I'm going to go down here. And now we have to classify this thing in the middle. So even though it started out as a kite, now it kind of looks like a rectangle, and we have to show that. So I certainly think it's a rectangle, so let's show that. A rectangle is 4 right angles, right? Or congruent diagonals, okay? You can do whichever one you want. I'm going to go slope this time. because what is the slope of this line right here? 0. What's the slope of that one? So isn't a horizontal and a vertical line always perpendicular no matter what? So you don't have to necessarily do a 0 times an undefined equals a -1 because that doesn't really make sense. But what you're going to say is slopes of vertical and horizontal lines are perpendicular, and that's what you have. So you have 4 sets of those. Okay, so this would be a rectangle. Oops, we're not answering yes or no. Rectangle. Now, would it be a square? No, because when you count, and I want to show you how easy it is to find distance if you're looking at this one. If you are looking at the distance across 1, 2, 3, 4, 5, 6, isn't the length going to be 6? Count the square. So unless it's angled, and then you have to do Pythagorean theorem, but if it's something that's straight, horizontal, or straight vertical, count them. So the length of this side would be 6, the length of this one would be 4. They are definitely not the same, so they would not be a square. So use the knowledge that you have. You just kind of have to describe it a little bit differently. So I'm going to say this one is a rectangle. It can't be a rhombus because the side lengths are the same. It can't be a square because the side lengths are not the same. So here would be rectangle. So we're going to do another one that's kind of like this one. So rather than take up more of your time, I want to have you guys do one. So let's stop here and we will do one together, and I'll tell you what it is in a second.